Hello, my dear students. Today we are going to continue our discussion on Chapter 1, which is the main transition elements. We are going to discuss the iron and iron ores and how iron is extracted from its ores, and we are going to discuss the types of alloys. So let us start. Iron. Iron has the symbol Fe and has atomic number 26 and has atomic mass 56. Iron is found in form of ores, as it is found in elementary state only in meteorites by 90%. Iron is found in the Earth's crust, which is the fourth most common element in the Earth's crust after oxygen, silicon, and aluminum. It forms 6.3% of weight of the Earth's crust, and its amount increases near the center of the Earth. The suitability of the ore for extraction of iron economically depends on the iron percentage in the ore, the composition of the impurities in the ore, and the type of harmful elements that mix it with the ore, such as sulfur or phosphorus or arsenic. Now, my dear students, we are going to discuss the important ores for iron. We are going to discuss the name of the ore and its molecular formula and its color and the percentage of iron in it and the property of iron ore and its occurrence. The first ore is called magnetite, has molecular formula Fe3O4 and has a chemical name magnetic iron oxide or black iron oxide. Its color is black. The percentage of iron ranges from 45 till 70%, and it has magnetic property, and it is found in eastern desert. The second type of ore, hematite, has molecular formula Fe2O3, has chemical name iron 3 oxide, has blood red color, and the percentage of ore ranges from 50 till 60%, and it is easily reduced, and it is found in oasis area. The third type of ore is called limonite, has molecular formula 2Fe2O3.3H2O and has chemical name hydrated iron 3 oxide. Its color is yellow. The percentage of iron ranges from 20 till 60%, and it is easily reduced, and it is found in oasis area. The fourth type and last type of the ores that we are going to discuss in our syllabus is siderite, has molecular formula FeCO3 and has chemical name iron 2 carbonate. Its color is yellowish gray, and the percentage of iron ranges from 30 till 42%, and it is easily reduced, and it is not found in Egypt. Now, my dear students, we are going to discuss the extraction of iron from its ores. The extraction of iron takes place by 3 stages. The first stage is called ore dressing, second one is the reduction of ore, and third one is a steel production. We are going to discuss the 3 stages in details. So we are going to discuss first the ore dressing. The first process we are going to discuss it is the ore dressing. Here, ore dressing takes place because of improving the physical and the mechanical properties of the ore and improving the chemical properties of the ore. And these two processes happens by 4 stages. First one, crushing for improving physical and mechanical property, and sintering and concentration of the ore. While to improve the chemical property of the ore, we have to make roasting. We are going to discuss each one in detail. In the crushing process, we are going to break down the ore to obtain suitable small size to be easily reduced as the following animation. As shown on the screen, the ore is broken down in suitable small particles. The second step we are going to do after crushing is the sintering process, which is the treatment or collecting the fine particles that resulted from crushing and cleaning the furnace to obtain similar and homogeneous larger particles. The third step in order to make ore dressing to improve the physical and the mechanical property of the ore is concentration, where we increase the percentage of iron in the ore by removing the unwanted impurities that are combined or mixed with the ore through using surface tension property or magnetic or electric separation, as the following animation show. As shown on the screen, my dear students, the iron ore that mixed with sand and impurities is going down into water and oil, so the oil that surround the iron ore float and can be separated, so we use a surface tension property in order to separate the impurities from iron ore. The second way for removing the impurities, that we are going to pass iron ore with impurities over electromagnet, in which we can separate the iron ore from the impurities. Now, my dear students, we are going to discuss the fourth step for ore dressing, which is to improve the chemical property of the ore, which is roasting, that heating the ore strongly in air, and so we have give reason for this process. In this process, we have to dry the ore to get rid of the humidity, and converting the ore into iron 3 oxide to increase the percentage of iron, such that if we use siderite or iron 2 carbonate, by heating it gives carbon dioxide and iron 2 oxide. Then iron 2 oxide is oxidized by air into iron 3 oxide. So we have increased the percentage of iron from siderite into iron 3 oxide, as shown on the screen. And also, if we use limonite ore, by heating it will be changed into hematite, which is iron 3 oxide. Also, we have increased the percentage of iron in the ore. My dear student, by doing roasting process, we make oxidation of some impurities. Here, for example, sulfur is oxidized into sulfur dioxide, and phosphorus is oxidized into phosphorus pentaoxide. Now, my dear student, after ore dressing, we are going to discuss the second stage for extraction of iron, which is the reduction of iron ore. My dear student, remember that ore dressing is done to improve the physical and the mechanical property of the ore and improving the chemical property. Then we are going to make the reduction of iron ore. Here, the reduction of iron ore takes place by 2 types of furnace. In blast furnace, carbon monoxide that obtained from coke, we reduce the iron ore into iron. Or by using matrix furnace, by the mixture of carbon monoxide and hydrogen that we call water gas, that can be obtained from natural gas, we can reduce the iron ore into iron. My dear students, we are going to discuss each one in detail. In the blast furnace or high furnace, the reduction process by carbon monoxide takes place as following. The coke forms reducing agent carbon monoxide, that carbon monoxide used to reduce the iron ore. As the following equation proceeds. Carbon plus oxygen by heating gives carbon dioxide. Then carbon dioxide is reduced by the carbon or the coke into carbon monoxide that can be used for reduction of iron ore, as the following animation shows. My dear student, here the iron ore and coke are going to be in the furnace from the opening at the top, and we are going to heat the blast furnace in order to make the process of reduction of iron ore as shown on the screen. My dear students, now carbon monoxide reduce the iron 3 oxide into iron as following. Iron 3 oxide plus carbon monoxide by heating above 700 degrees Celsius gives iron and releasing carbon dioxide gas. As the following animation will show how can this be done. Here, my dear students, the iron ore and coke are going to be fed to the blast furnace from opening at the top of the furnace in order to make the reduction process, where the coke is heated to form carbon dioxide, and carbon dioxide reacts with coke, forming carbon monoxide that reduces the iron 3 oxide. Now, my dear students, we are going to discuss the second way for reduction of iron oxide, which is hematite, iron 3 oxide. We are going to use the matrix furnace. Here, we reduce the iron ore by mixture of carbon monoxide and hydrogen gas that we call water gas. This mixture is resulted from the natural gas, which contains 90% methane gas. As the equation proceeds on the screen, methane plus carbon dioxide plus water gives mixture of carbon monoxide and hydrogen gas. This mixture is used to reduce the iron 3 oxide, which is a hematite ore, in order to get iron and releasing carbon dioxide gas and water vapor, as the following animation shows. The iron ore is placed from the top opening of the furnace, and then the water gas is passed over it to reduce the iron 3 oxide into iron. Now, my dear students, we are going to discuss the third stage for extraction of iron ore, which is the steel production. In the steel production process, we are going to remove the impurities from iron that come from reducing furnace, and we are going to add desired elements to iron, giving the steel required properties. We have 3 types of furnace in order to make the steel. These different types of iron, such as cast iron and steel, can be obtained from these different types of furnace, which are oxygen converter, open hearth furnace, and electric furnace. Now, my dear students, we are going to discuss the alloys. My dear students, alloys, the concept of alloy means that when 2 or more metals are mixed together, as iron and chromium, or iron and manganese, or iron and nickel, they are mixed to form alloy. And here we can form the alloy by using metal mixed with other non-metal such as carbon. How can we prepare the alloy? So we are going to discuss the preparation of alloys. The first way, by melting. melting metals, then mixing them together with the desired ratio and leaving them to cool gradually. The second way, by electrode deposition. Here, the electrode deposition of two metals or more at the same time using electrolytic cell with the object to be plated must act as cathode, and the electrolyte in the salt solution of the metal, such as in brass, that we place zinc and copper salt solution together to make the brass. So the example for making alloy by this way is the electroplating of iron handles with brass, which is made of zinc and copper. Now we are going to discuss the types of alloys. Here we have three types of alloys. The first one is interstitial alloy, second one is substitutional alloy, and third one is intermetallic alloy. We are going to discuss each one in details. The first type is interstitial alloys. In this type, the alloy is formed when new small size atoms are introduced into the space between the metal atoms in the crystal lattice shape, so preventing the movement of the metal layers, and this will increase the hardness of the metal and change the physical property of the metal, such as malleability, ductility, melting point, electric conductivity, and magnetic properties, and also the strength of the alloy, which make it harder than the pure metal. For example, iron-carbon alloy, which is steel. The second type we are going to discuss is the substitutional alloy. Here, the alloys are formed when the introduced atom replaces some of the metal atoms in the crystal lattice shape, and this occurs when the introduced atoms have the following conditions: nearly the same diameter, same chemical properties, and same crystal lattice structure. For example, for substitutional alloy, gold-copper alloy, iron-nickel alloy, ferro-chrome alloy that used in stainless steel. Now, my dear students, we are going to discuss the third type, which is intermetallic alloy. My dear student, in this type, the alloy is formed when the elements forming the alloy combine with each other to form chemical compound with new properties. Here, the formula of the formed compound disobeys the law of valence. Also, the formed compounds are solids and cannot be formed by metals of the same group. For example, nickel aluminum alloy and copper aluminum alloy that called duralumin, and also another example, lead gold alloy that has chemical formula Au2BP, and third one is cementite alloy that has chemical formula Fe3C. Now, my dear students, we are going to discuss some questions on this part. The next type of question is a scientific term. Alloy of two elements or more, their atoms have the same diameter, chemical properties, and crystalline structure. If you think about it, yes, the answer it will be substitutional alloy. Next point. One of the iron ores which has a blood red color. Yes, the answer is hematite. Next point. The furnace which uses carbon monoxide gas to reduce hematite. Yes, the answer is blast furnace. Next point. The iron produced from the oxygen converter. Yes, the answer is steel. The process in which fine iron ore particles are collected to obtain large ones. Yes, the answer is sintering process. Next point, heating iron ore strongly in air to expel humidity and to increase the percentage of iron. Yes, the answer is roasting process. Next point, an alloy formed when its elements are chemically combined together. Yes, the answer is intermetallic alloy. The next type of question is give reason for. Iron ore is heated strongly in the air during extraction of iron because of drying the ore to get rid of humidity and also converting the iron ore into iron 3 oxide that increase the percentage of iron, such that when heating iron 2 carbonate, which is hydride, gives carbon dioxide and iron 2 oxide, then oxidation of iron 2 oxide gives by air into iron 3 oxide. Then if we use limonite as ore, by heating it gives hematite and releasing the water vapor in the air. Next type of question, what is meant by alloys? Two or more metals can be mixed together to form alloy, which also may be formed by metal and other non-metals such as carbon. Interstitial alloy. The interstitial alloy formed when new atoms are introduced in the spaces between the metal atoms in the crystal lattice shape, due to their small size causing a change the physical properties of the metal, malleability, ductility, melting point, and electric conductivity, and magnetic property and the strength of the alloy to be harder than pure metal. And for example, iron-carbon alloy that we call steel. The substitutional alloy, it is formed when the introduced atom replaces some of the metal atoms in the crystal lattice shape. And this occurs when the introduced atoms have nearly same diameter, same chemical property, and same crystal lattice structure. For example, gold-copper alloy, iron-nickel alloy, and ferrochrome alloy in stainless steel. The intermetallic alloy. They are formed when the elements forming the alloy combine with each other to form a chemical compound with new properties. And the formula of the formed compound disobeys the law of valence. And the formed compounds are solids and they cannot be formed by the metals of the same group. For example, nickel-aluminum alloy and the copper-aluminum alloy that called duralumin, and lead-gold alloy that has chemical formula Au2Pp, and cementite alloy Fe3C. So choose the correct answer. All the following compounds are iron ore except what? Magnetite, limonite, dolomite, hematite. If you think about it, my dear student, you will find the answer is dolomite. Next one, iron is found in free state in what? Earth's crust, meteorites, sideриtes, alumina. If you think about it, yes, it will be meteorites. The third point, or next point, on heating iron 3 oxide in the presence of a mixture of carbon monoxide and hydrogen gas, it is reduced to what? Iron 2 oxide, or magnetic iron oxide, or iron, or mixture of iron 2 and iron 3. If you think about it, my dear student, yes, your answer will be iron. Next point, on heating iron 3 oxide with carbon monoxide gas, it is reduced to what? Iron 2 oxide, or iron, or magnetic iron oxide, or mixture of iron 2 and iron 3 oxides? If you think about it, yes, it will be iron. Next point, the furnace that reduces iron ore by water gas is what? Blast furnace, electric furnace, matrix furnace, oxygen converter. If you think about it, yes, it will be matrix furnace. Next point, the furnace that reduces iron ore by carbon monoxide gas is what? Is it matrix furnace, or blast furnace, or electric furnace, or oxygen converter? If you think about it, yes, the answer it will be blast furnace. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today. So till we meet again, my best wishes for you.